Okay, so we're going to look at finding the length of the hypotenuse. So the hypotenuse we talked about last lesson a little bit. So what we're going to have on our right angle triangle, so just draw it up here, we said this length here opposite the right angle was the hypotenuse. So here, this is the hypotenuse here, because it's opposite that right angle there. And the hypotenuse is always the longest side of a right angle triangle. And in terms of numbering, labeling, etc., we call this length to be C. Okay, so in terms of hypotenuse, that's the hypotenuse. Length, well, we're dealing with a triangle. We can measure all the sides, measuring distance, length. So grabbing an example, the question's going to look something like this. It's going to have a right angle, and it's going to say this will be 3, this can be 4, and this can be x. So you need to go through and find the length of the hypotenuse on this triangle here. So to find the length, what we're going to do, we're going to go back to our good friend Pythagoras Theorem. So Pythagoras Theorem we talked about last lesson. We said that a squared plus b squared equals c squared. And that was our rule. Always come back to that in terms of this question here. So Pythagoras' theorem, in case you missed it, is connecting 3 sides of a right angle triangle. A is a side, B is a side, C is a side, A, B, C. So 3 sides here, 1 side, 2 sides, 3 sides. 1, 2, 3 sides. Labeling it correctly, back to our labeling. Opposite the right angle was our hypotenuse, and last lesson we said this is C. It's still the same today, it's still going to be C. Other sides, doesn't matter, A and B. So getting into actually doing a question then, we said, pulling it over here, if we have this here, labeling a squared plus b squared equals c squared. Here a is 3, so it becomes 3 squared. B squared, b is 4, so 4 squared. And we don't yet know what c is, so c is just going to be x here. So 3 squared plus 4 squared is going to get us x squared. Now we can't do a whole bunch with the x squared right now. We will square root soon to cancel that squared off, but we're going to work with this side here first. 3 squared, firstly, 3 squared is 3 times 3, and 3 times 3 is 9. 4 squared is 4 times 4, 4 times 4 is 16. That's still equal to x squared. The x squared has not changed at this point. 9 plus 16 is 25. And now we will work on getting rid of the squared here. Now it's just equal to one thing. X squared is one thing. We're going to square root both sides. And square rooting will cancel with the squared here. Squared and square root will undo each other, so they cancel. Okay, that leaves us here with just an x. So in the same way, solving a normal equation, you might plus 3 minus 3 would cancel, or times 2 divided by 2 would cancel. Here, squared and square root cancel. They undo each other here. So if I've got squared, I'm square rooting both sides. So that side cancels, just x. This side here, square root 25. I can reach for my calculator to do that. I can literally put it in as it looks there. So on the calculator, square root 25, put that in. That gets me that x is going to be 5, or 5 equals x. So if I put units on, say I put it all in centimeters, doesn't make a difference, x centimeters here. It's just saying that x is 5 centimeters. Okay, so you can write it this way, the other way, it doesn't make a big difference at all. Okay, taking another example, let's get some clear space. If I've got the length here of 5 and 12, and they can both be in meters. This will be x meters again, and my right angle is going to be right here. So approaching my problem here, I'm looking at Sides, this is a side here. So I've got one side, I've got a second side here, I've got a third side here. 3 sides, one of them I don't know. 3 sides, right angle triangle. I'm reaching for Pythagoras Theorem. So our good friend Pythag. Okay, labeling what we've got, we're going to have, well, Pythag says a squared plus b squared equals c squared. So going through this, a, b, and c, what is going to be what? The right angle is there. Then opposite that is this thing here. That's going to be c. Okay, just like we've done many times before. That's a, and that is b. So substituting into my equation here, a is 5, so 5 squared, plus b squared, b is 12, equals c squared, c is x, so x squared in there. Working this side, 5 squared is 25, 12 squared is 144, it's still equal to x squared, hasn't changed. 25 plus 144, reach for the calculator if you need to, that's 169, is x squared. Here, we've now got x squared equals something by itself, whereas up here it's 2 separate things. So we do work those 2 separate things, get it down to 169 here. We'll square root both sides to cancel. Squared, square root cancel there, so we get x here. And on this side, on the calculator, square root 169 gets us 13. So x here is 13, and the units from my question is 13 meters. So that is x in there. So all we're doing really here is taking what we knew from last lesson, substituting into my equation. So from last lesson we had this, that's familiar, putting it into our equation here. The difference here is today we do have this unknown here. Okay, and then from there we're applying some solving equation skills, simplifying this to get x squared is 169, square rooting both sides to get us that unknown length there. X is 13. That's all for now. Thanks for watching.